Okay, let's try to figure out domains of functions and also domain of sum of functions and compositions. First, let's think about the domain of x plus 5 over x squared minus 5x plus 4. Well, when you have a fraction, what do you have to be careful about? When the denominator is 0, you have trouble, right? So you have to know when the denominator is 0. And one quick way to figure that out is by factoring the denominator. And you can rewrite this as x plus 5 over x minus 1 times x minus 4. And that means anything other than 1 and 4 are okay. Good? When x is 1 or x is 4, then it's dangerous. So we're going to draw a number line, say that everything except 1 and 4 are okay. Taking these 2 points out and putting an open circle, that breaks the the real line into 3 intervals, right? The first interval being negative infinity until 1. Second interval is 1 to 4. And then the last interval is 4 to infinity. And you put unions if you have more than one interval. Kind of straightforward, right? Good? Okay. Next, domain of g of x. What do you have to be careful about when you have a square root? You can't have negative inside the square root. That's the problem, right? So for this, you have to say the thing inside 5 minus 2x has to be 0 or positive. And that one can be solved just by subtracting 5 both sides and then dividing by negative 2 both sides. Oh, and whenever you divide or multiply by a negative number in an inequality, what do? You flip the sign of the inequality, so x is less or equal to 5 over 2. On the number line, this means here's 5 over 2. Everything before and including, you put a close circle here, including 5 over 2 is okay, but afterwards it's not okay. So you just have this single interval as the domain. The domain of g of x is from negative infinity until 5 over 2. Okay. Any questions so far? Kind of straightforward. Okay. Now comes the part where we have to think a little bit. The next question is, what's the domain of f plus g? Well, this symbol simply means it's the function obtained by adding these two. So the function that we're discussing here is x plus 5 over x squared minus 5x plus 4 plus square root of 5 minus 2x. So we have this single function where the two functions are added. You get this single function. And we have to figure out the domain. Remember, domain is the set of numbers where it's allowed to be plugged in. I know that as long as x is 5 over 2 or less, you can plug it in here without causing any trouble. Agreed? Okay? It's good? Okay. On the other hand, this one, you're not allowed x to be what? What's not allowed here? 1. And then 4. 4 is also not allowed. And as long as the numbers are not 1 or 4, you're allowed to plug it in here. Then the question is, what's okay for both functions? As long as it's before 5 over 2 and it's not 1. Okay? You get it? You have to say, for the numbers to be okay for this one, can't be 1 or 4. For the numbers to be okay to be plugged in here, it has to be 5 over 2 or less. So in here, 5 over 2 or less, 1 is not allowed. You take that out, and you end up with how many intervals? How many intervals do you see? You have one here, another one here, right? So you end up with the following answer. One interval starts from negative infinity, ends at 1. Union, it doesn't include 1, so I have to use open interval. And at union, it starts at 1 and ends at 5 over 2, and 5 over 2 itself is included. So that's the domain of f plus g. So that was a little bit more challenging than before, but after giving some thought, you probably understood why that's true. Okay? Now, let's move on to the most challenging part, the domain of the composition of two functions. Right? Now, before we think about this, of course, we need to know what this means. This small circular thingy here, that's called the composition. It means f composed with g of x. And it means you're plugging in this function into this function. In other words, you're trying to plug in into f this function, which is square root of 5 minus 2x. Okay? One thing that you have to know is how to actually express this. Well, to compute the composition, you should do two-step procedure, which is first copy the definition of the function. So I'm copying this definition here. But anytime x appears, you're going to put a parenthesis. Just like that. Okay. That's step one. That's how you compute the composition of two functions. Now, step two, what should we do for step two? This is our goal. I want to know what this is. Plug in square root of 5 minus 2x, right? So this is what goes inside every vacant parentheses that you see. Now all the blanks are filled in, and that's the function that we are discussing. Okay, and the question now is, what's allowed to be plugged into this function? And that's a lot more challenging than before, so let me just erase all the previous one and just focus on this one. I still want to write down some of the answers. Remember, this one, the requirement was it has to be less or equals to 5 over 2. And for this one, the requirement was that x cannot be 1 and x cannot be 4. Those are the requirements. Okay. Now, looking at this, does this still apply? Why? The function's still there. So because you still have a square root, you still need your x to be before 5 over 2. That's what's needed. However, this doesn't directly apply. What you need to do is that if this value becomes 1 or 4, then we have a problem. Do you understand what I'm saying? If this value becomes 1, what happens? You get 1 squared minus 5 plus 4, that's 0. If you plug in 4, that's also 0. 1 and 4, if square root of 5 minus 2x, because that's being plugged into f, if this value becomes 1 or 4, is that okay? No good. it will be bad because it will make the denominator equal to 0. Okay? So let's see what that means. This will, so this means are not okay. You guys should put a red letter. Not okay. Bad. Okay? Okay, so first thing, I square both sides. And move the 2x there, subtract, and then we get 4 equals to 2x, so x equals to 2. In other words, when x is 2, 2 times 2 is 4, 5 minus 4 is 1, square root of 1 is 1. You end up with 1 being in here, and that will make the denominator equal to 0, and that's bad. So that's the first one that's bad. Bad. Let's do the same thing here. Square both sides. If you square both sides, you get 5 minus 2x. The square root goes away when you square. What's 4 squared? 16. And you can add 2x both sides. Subtract 16 both sides. And 5 minus 16 is negative 11. And you just have 2x, so you get x equals to negative 11 over 2. And that's again bad. All right, so we've done that hard work. Now we're almost there. Just bear with me, we're almost there. Okay, look. 5 over 2. So when x is between negative infinity to 5 over 2, it's okay to compute that square root. We don't have any problem. But if x is 2, this is right before this, so x is 2, or somewhere here, this is negative 11 over 2, these values will make the denominator equal to 0, so those are bad. Okay? Got it? Okay. Now, how many intervals do you have? 3. Okay. So now we can write down the answer to part B, which is the domain must be negative infinity until negative 11 over 2, union negative 11 over 2 until 2, union, tell me the last one. 2 until 5 over 2, and then close break. That's what's needed.